Let's discuss different types of strain. In the previous section we have studied that there are three kinds of strain, depending on the change in dimensions due to applied force. The very first is longitudinal strain. And in case of longitudinal strain it is accounted for change in dimensions of length. Like for example, there is a rod which is clamped at one end, and in this situation say if an external force is applied onto it, in outward direction, due to which, the length of rod is elongated by a distance, delta L, and say L was the original length of the rod, then in this situation the longitudinal strain can directly be written as delta L by L, as delta L is the deforming dimension or the dimension deformation and L was the original dimension, along the length of the rod. So this, delta L we can say, is the elongation. And it can be compression also. If the force is applied in inward direction, the rod would have been compressed. So this is the way how we account the longitudinal strain in case of a rod. The second one is volume strain, which is generally accounted for the cases of fluids. We can write generally used in fluids, as in case of fluids dimensions are not defined, only volume can be defined. So we can simply state, say, we are having a container in which a liquid is filled, and over the liquid a piston is there, and we apply an external force F, and due to the force an excess pressure is developed, and say, the piston compresses the fluid by some distance delta x, then we can say the volume of this fluid will be decreased. So in this situation, the volume strain of this fluid can be written as delta V by V, where V is the initial original volume of the fluid and delta V is the decrease in volume due to the applied pressure, excess pressure or the external deforming force. Similarly we can say, if there is a fluid body on which from all directions an excess pressure is applied, then due to this excess pressure it may be possible that the size of body will get reduced. Then say if this is the decrease in volume of the body, if this decrease in volume is delta V and original volume of body was V, then volume strain can be defined as delta V by V. For solids generally in all dimensions we define longitudinal strain. And in case of fluids, liquids or gases, when we talk about their deformation and elasticity we define volume strain in terms of the ratio of change in volume to the original volume. Now the third type of strain is shear strain, which we have discussed. In the previous section it is deformation due to tangential force, so we can write it as, it is the tangential deformation in a body due to shear stress. So we can say, we just take the similar case that we take for understanding the shear stress. Say if there is a body which is fixed at its bottommost point, and a tangential force F is applied onto it, the body will get deformed slightly in tangential direction, say by an angle theta. Say if the height of body is h, then its tangential deformation is x. In this situation we can define shear strain as the deforming length x, divided by the actual height of the body in which the deformation is taking place, which is approximately written as theta, which is generally taken as small angle. Then only we can take shear strain as theta. When bodies are highly elastic, then these may get deformed to large angle. In that case we cannot directly use this expression, but in most of the cases which are available in our surrounding or we will deal in this section, we will take shear strain as deforming length, tangentially divided by the total length of the body in which the deformation is taking place, normal to the tangential direction.